The first lesson, we talk about the mean, which is a measure of center or also a measure of central tendency. And it's one of the measures that we use to talk about the sort of middle of a group of data, right? So we might talk about the average heights of all of the pupils in a class, and we might say the average height is 5 foot and 7 inches. Maybe if we had a class of adult students in galvanized immersive, for example. So there are a number of ways that we can express a measure of center. We can maybe express the most common height or maybe the median height, right? You'll hear in the news difference between a mean income or a median income, the average household value, the average house value versus the median house value, right? These are both measures of central tendency. We're going to talk about the difference between those and why you might want to use one over the other in specific situations in a couple of lessons. But for now, just focusing on the mean, right? What exactly is the mean, right? And you might be familiar with this already. A mean is probably something that you know as the average, right? And it turns out there are actually a few different kinds of means or geometric means, but what we're talking about specifically is the arithmetic mean. And if we actually look at this formal definition of it, we have a little bit of mathematical notation to break down. And I'll make this a little bit larger so you can see, right? Let's just quickly recall that what we are doing here with this summation symbol, right, this capital epsilon, is that this means that we have some series of numbers that we are going to add up, right? Or a series of expressions that we are going to add up. In this case, we have a series of numbers, each one that we are going to express as a sub I, right? And then we're going to start with I equals 1 and go up until I equals n, right? And n is equal to the number of objects we have. So I'll just scroll down here a little bit so we can see right now I actually have a data set. So we're going to say a sub 1 is 1, a2 is 2, a3 is 3, so on and so forth, right? So what this is saying is I'm going to multiply 1 over n times the sum of every item in my list, right? So 1 plus 2 plus 3 plus 4 plus 5, right? And this is the average that we know. We take up all of the items in the list and we divide by however many there are, right? There are n items in our list and we're multiplying by 1 over that number of items, right? Which is the same as multiplying by 1 over n. That's the same as just dividing by n. So let's go ahead and jump over into Python. I'm going to be working in both VS Code with a terminal over here. I'm working in my local environment. If you don't have a local environment set up, you can work in Replit. You could also work in like a Google Colab maybe, right? If we search for that really quickly, right, we could get to a notebook where we can execute code really quickly, right? And I could open a new code box, right? And I can print the string hello world here, right? And I can execute that cell. The first one, it takes a second to actually connect and get you to a Python server, right? But after this, it should move pretty quickly. I can run my Python code here. Replit, I'm not signed in right now, but I could sign in and start up a Replit. But I think if you've worked through most of our intro and intermediate Python stuff, I think you should start to get your local environment set up. I'm going to put a link in the description to our setup materials so you can sort of take a sidebar and get set up there. It's something that you're going to have to do eventually anyways, right? But, right, I've got this list of values, right? We're going to go over and we're going to use Python to find my sum, right? The first thing I want to do is I want to save these values. I'll do it as a list and I'm going to just call that list. At first, I'm not going to use any built-in functions. I'm going to do this sort of brute force. I'm going to say for each number in my list, right, let's add to the sum. And then at the end, let's say that my mean is equal to the sum divided by the length of that list, right? Or the number of items in that list. And in the end, right, I'm going to want to print my mean. And I can go over into my terminal. I can say Python, and I've just named this file delete me.py. I'm just working on my my desktop. Looks like I've missed something here. That's because I've added 0 each time instead of adding the number. That's silly. Of course, my average is going to be 0. And now I can see that my average is actually 5.5. Right? Of course, we can do this more efficiently. Instead of doing this accumulator, I can just use the built-in sum function. I can just say, let's go. The mean is equal to the sum of my list over the length of my list. Right, again, if I do this, I get 5.5 right back. That's even more efficient, but maybe even the best is if I were to have imported NumPy as NP, and you may not be familiar with NumPy yet, and that's okay. I would just maybe check out Google, do a little bit of reading about it, and check it out, right? But let's say, let's just use np.mean, and let's throw our list in there, right? And now if I actually check this out, it takes a moment to read in that library the first time, and I can see that my value is 5.5 as well. If I wanted to do that a little bit more efficiently, I could say from NumPy import mean, right? And then I would just have to be careful here, right? I'm no longer going to use np.mean, and then I'm going to have to be careful with my variable name here, right? That's now something that I've imported, right? So that variable name is already taken, so I have to use something else. Looks like I'm just getting a function here. Right. And I get 5.5 this way. Nice and efficient using NumPy as well. So, that's the mean when we talk about it as the average. In terms of notation, you will see some different notations for the mean. A lot of times in statistics, you're going to see this character that looks a little bit like a U. This is actually called mu. It's a lowercase Greek letter mu. This is typically used for the population mean, but you're just going to be seeing it used for the mean in general a lot. You'll also see X bar. In general, when you see a bar over a letter, that's going to often mean some sort of average, right? But in this case, we're talking about X bar. This is actually a sample mean, right? Where the mu is a population mean. And then a capitalized X bar is actually talking about the mean of a random variable, right? So that's almost like an average of averages, right? And as we get towards the end of this course, we're going to be talking a lot about that as we get into inferential statistics, using our probability theory to talk about inferential statistics. But for now, sticking to descriptive statistics, we're mostly going to be seeing mu and the lowercase x bar. Now, when we talk about a population versus sample, right, there are going to be some differences in the calculations that we're making, and it's just important that we're sure that we know what a population and what a sample is, right? And when we talk about a population, what we're talking about is any time that we're encompassing all of the possible data points, right? So it doesn't necessarily have to be like all of those things in existence, right? So I could have maybe a situation where a farmer owns 1,000 cattle and he wants to find the average weight of his cattle, right? He could either do so by taking a sample of 100 of those cattle, or he could get the entire population of his cattle, right, and take the 1,000 weights and find an average from those 1,000 weights, right? A population doesn't have to mean all of the cattle in the world necessarily, right? It just has to mean all of the possible data points for whatever group it is that you're talking about, right? So there are some times when we have access to an entire population, right? But more often than not, when we're talking about statistics, what we're going to be trying to be doing is making inferences about a population from a sample, right? Unfortunately, we just have to get through a bunch of probability stuff before we're really able to start doing that. So that's the difference between a population and a sample, right? Population represents all of the possible data points, where a sample represents just some subset of that population, right? There's a bunch of different sampling techniques. Generally, you want that to be random and equally representative. You wouldn't, if you were taking average heights of Americans, you wouldn't want to go to an elementary school and choose all school children, right, for your sample of heights, right? That's not going to be very accurate. So that's the difference between population and sample. There's no difference on calculating the mean, right? But when we get to the variance and the standard deviation, it will be. So we saw how to find the mean using Python a little bit already. That's really it for this lesson. There's a few challenges here for you to solve. Go ahead and do that. I would encourage you to use Python instead of doing it paper and pencil. But that's it for this lesson. I'll see you in the next video where we're going to talk about the median.